Let's solve this pretty straightforward problem, monotonic array today. Write a function that takes an array of integers and returns a Boolean representing whether the array is monotonic. An array is said to be monotonic if its elements from left to right are entirely non-increasing or entirely non-decreasing. Non-increasing elements aren't necessarily exclusively decreasing, they simply don't increase. Similarly, non-decreasing elements aren't necessarily exclusively increasing, they simply don't decrease. Note that empty arrays and arrays of one element are monotonic. So let's break it down further. An array is monotonic if it is either monotone increasing or monotone decreasing. If it's monotone increasing, the element after should always be equal or bigger in value than the element before. Conversely, if the array is monotone decreasing, the element after should always be equal or smaller in value than the previous element. For example, let's take a look at these two test cases. Test case 7 is monotonic because each element after the previous element is smaller in value, satisfying the condition of monotone decreasing. Test case 8, on the other hand, is not monotonic because negative 900 is larger than negative 1100 in value, which breaks the rules of monotone decreasing. We can solve this by running through the array once because we want to check every element until the end of the array and compare the adjacent elements to see if they break the rules of monotone increasing or monotone decreasing. The way I solved it is to first check if the array has no length or has a length of 1. If it does, return true. Then within the for loop, for each element, I want to check if the array is in ascending order first by comparing the first two elements. If it is, the previous element is bigger than the current element, immediately return false. And if the array is in descending order by comparing the first two elements, and we find that the previous element is actually smaller, we also return false immediately. After the for loop is done looping, if nothing breaks the rule, we return true. If two adjacent elements are the same, we simply keep moving because that could indicate it's either monotone increasing or monotone decreasing, so it doesn't affect our overall return value. And we run the function, everything passes. The time complexity of this solution is O of n because we need to loop through the whole array, and auxiliary space is O of 1 because it's iteration.